All right, for section 3.6, I'm splitting it up into two different sections. One is on slope-intercept form, and the other one will be on point-slope form. So for slope-intercept form, that is y equals mx plus b, where m is your slope and b is your y-intercept. So for example, if you had an equation that looked like this, 2 would be your slope and -3 would be your y-intercept. So moving on here, example 1, write the equation of the line that passes through these 2 points in slope-intercept form. So we have two things to find. We have to find the slope and we have to find the y-intercept. So number 1, we have to do slope. And when we have 2 points, we have to use the formula y2 minus y1 over x2 minus x1. So y from the second point would be 2. Minus y from the first point would be 4 over x from the second point is -1 minus x from the first point is 0. So 2 minus 4 would give us -2. -1 minus 0 is going to give us -1. Two negatives are going to cancel here for division. 2 divided by 1 is 2. So our slope is 2. Now step 2 is to find the y-intercept. And we do that by plugging in the slope and 1 point. And it doesn't matter which 1 point you plug in up there, you'll get the same answer. So I'm going to pick 0 and 4 just because they are easier numbers to work with. They're both positive, or there's no negatives. -1, 2 obviously has the negative in it. So in the form of y equals mx plus b, I'm going to plug in the 2 for the m. In the ordered pair 0, 4, x is 0 and y is 4. And then we have to figure out what that plus b is. So we simplify that. 2 times 0 is 0. So we have 0 plus b on that side, and we have 4 over here. 0 is worth nothing, so I can get rid of that. B would be 4. So I have my m and I have my b, so I can now write y equals 2x plus 4. So if that 4 came out to be negative, we would write -4 there in the equation, but it didn't. Also, I want you to pay attention. We didn't actually have to do step 2 here. I did it so you had it for your notes and to look back on. But because this ordered pair x is 0, wherever x is 0, the other number, the y value, is your y-intercept. So I knew that looking in, but I know you guys didn't. So I needed you to see how to find it in case you didn't know that or didn't remember that. And they're not always going to give you an ordered pair where x is 0. So you're going to have to do step 2 on some problems. All right, example 2 says write the equation of the line with a slope of 0 that passes through 4, 6 in slope-intercept form. So this problem is similar to example 1, except for we already know the slope. So step 1 is already done for us. So we can plug in y equals 0x plus b. That's what we know by being told the slope is 0. Now we're going to plug in the x and y values, 4 and 6. So y is 6 equals 0 times 4 plus b. 0 times 4 is 0. 0 plus b is going to be 6. So b equals 6 here. So then we have to write all of that. It would look like that, but we actually don't write 0x because 0 times anything is always going to be 0. It's going to cancel out. So we don't need that part in there. We just need y equals 6. For example 3, we're going to graph this. And the way we do that is number 1 is graph the y-intercept first. Let's see. So that would be a +3. So on the y-axis, we're going to put a dot at +3. And then step 2 is do the rise over the run from your y-intercept point. So our slope here is 3/2, so that means we rise 3 and run 2. 1, 2, 3, 1, 2. So our new point is here, and then we can connect those two dots to have our line. All right, example 4, we are going to graph x equals 3. This is not in the form of y equals mx plus b. There is not a y. So what we know is x equals 3. So on the x-axis, we're going to put a dot at 3. And whenever x is 3, no matter what we plug in for y, we can't plug anything in for y. Y can be anything, but x is always going to be 3. So we can pick any points on here where x is 3. So we go over 3 and we can go up or down whatever we want. So whenever we have x equals a number, it's just going to be a vertical line through whatever number it says. All right, now pairs of lines. So how to tell if they're parallel, intersecting, or coinciding. So parallel means they're never going to touch, and that happens when they have the same slope but different y-intercepts. Intersecting lines means they're just going to cross each other at some point, and that's when there are different slopes. And coinciding lines means they're the exact same line. So they pass through every point together. They have the same slope and the same y-intercept. So example 5, we have to determine whether the lines are parallel, intersecting, or coinciding. So looking at these, let's take a look at our slope. So the number in front of x, same slope. So we know now that they're either parallel or they are coinciding. And then we look at, the y-intercepts. Those are different, +3 and -1. So different y-intercepts. So go up here, same slope, different y-intercept as that first one. So that tells us they are parallel. All right, part B, same thing, only we don't have both equations solved for y. So this has to happen before we can compare. So I'm going to solve this equation for y. So we're going to move this 6x. So I have -2y left and 10 minus 6x over here, because remember they're not like terms, so we can't combine them. And then I have to divide everything by -2. So y equals 10 divided by -2 is -5, and -6 divided by a -2 is a +3, and that's where the x is. So I'm just going to flip this around. We have a +3x and a -5. So now looking at these, 3x minus 5, 3x minus 5, they're the exact same. So these lines coincide. All right, and then for part C, again, neither one of them are solved for y, so we need to do that first. So -3x here. So we have 2y equals 7 minus 3x. And then we have to divide everything by 2. So y equals 7 divided by 2 doesn't come out evenly, so I'm going to leave that. Same thing with -3 divided by 2. I'm going to leave that with an x. I am going to rearrange. So it's mx plus b form. And then over here, the only thing we have to do is divide by 3 to solve for y. So we have 4 over 3x. And we have 7 over 3. So now looking at the slopes, we have -3/2 and we have 4/3. They have different slopes, so if we go back up here, the only thing that has different slopes is intersecting lines. So that tells us this is intersecting. All right, example 6, our last example here, says that Audrey is trying to decide between two health club plans. After how many months will both plans' total costs be the same? So, in other words, when will they be equal? But they don't give us equations for each plan, they give us the prices. So, for plan A, we have to pay $140 to enroll. Plus, we have to pay a $35 per month charge. And then for Plan B, we have to pay $60 to join and then $55 a month. So they want to know, when are these two going to be equal? So then this becomes a review problem. We have to solve for x. We have x's on both sides, and I always said it's easier to move the smaller one, so we're going to subtract 35x from both sides. So we have 140 here, 60, and 55 minus 35 is going to be 20x. Then I'm going to minus 60 from both sides. 140 minus 60 would leave us with 80 equals 20x. Divide both sides by 20 here, so x equals 4. So how many months would their costs be the same? This will be after 4 months.